using my screen, my face, microphone. We have a really cool setup right now. So everything is in the title. We talk about how to write a Node.js language in Rust. And first disclaimer is the NPM module we will talk here can't run in the browser. It's part of the thing. It's for Node.js, not for Webpack or something else. Yeah, it's not wasn't meshed, so we're talking very different way to use Rust with JavaScript. And yeah, why? There are several reasons. The first one is you not always have a team full of Rust developers. Sometimes you have few people knowledgeable about Rust, and most of the developers know JavaScript or work with Python or another language. And I think it's a good idea to mix programming language. Maybe it's an unpopular opinion, but there is no programming language that is good at everything. And I think Rust is not good at everything. It may be a good language to write critical code, but not for the rest of your code base. You may want to have in more easy and accessible language. So it's kind of cool to actually be able to write some critical part in Rust, the rest of your application in JavaScript, and to be able to interoperate these two parts. And the second reason is sometimes you work with code you don't write yourself, and you can't afford to rewrite because it's pretty costly to rewrite something, or just because the code you want to use is some libraries that have been proven or audited. I think mostly about cryptographic primitive, for example. You will not rewrite it in JavaScript even if you can, because you want to use that Rust libraries that have been proven and you can trust it and so on. So that's the two main reasons for mixing programming languages. I talk about Rust and JavaScript, but that's general concern. And there's already something that allow you to write Node.js language fully in Rust. It's called Neon. It's the main web page. You have some code examples, a bit small, but Rust code does not look like real Rust code. You have a lot of Neon construct. And I choose to not make this presentation about how to use Neon, because there is like documentation, NAPL reference, this kind of stuff. And I think learning how to use a framework is less interesting than understanding how that framework works. So this presentation is about doing exactly the same things as Neon, but without any framework, just to understand how that works. So this talk is about FFI, which is the shorthand for Foreign Function Interface, some system programming features that most languages have. That's the idea I will talk about, and that's an occasion to talk a bit about memory, how program works, this kind of general concept. I will switch to the demo. Yeah, so that's my computer. I made a directory called snip, it's the name of the trap here. And I created using something like cargo, new --lib snip. So new, yeah, like that. I already done that. And so I have a folder with several files, some JavaScript file, some Rust file. These two bits are a Rust file. This is my own stuff. This is JavaScript file, and this contains Rust project. I have little magic things that just pull code example from demo and just make it more easy to me to not copy paste chunk of code while presentation. So I will run it right now. Ooh, it's automatically can update socialib.rs. So I will look at what my Rust code looks like, and it's just a simple add function. Take one number and another number. It makes an addition of the two numbers, returns them, and you have this Rust type notation, 32, 32, 32, everything all right, and the function is public. I have to do that because otherwise you say that the function is never used, and I don't want that. What else does I have? I have script file, my JavaScript file, import some special node package which is called FFI, and API. And API stands for Node API. That's the way that Node try to make interface it with its table across new release of Node. Basically, I have some code about dynamic library, because what I will do is compile dynamic library. I will talk about it later. Maybe you already meet those kind of files. There are different. They're OS specific. For example, on Windows, that's DLL files. Linux SL, OS delete. I will explain later what dynamic library is. I have some special code f5.library load it, and then I can declare my signature function. So here I declare that I have an add function that's int, take int and return an int. So it works as a syntax switch bracket here again. The idea of this code is I will load a function which is not defined in JavaScript, but is defined in Rust. That's what foreign function interface means. That's my function didn't exist in JavaScript, it exists in another language. So that's what my code do. And to make that work, I have a few automation. I have one in package.json. Actually, this is fun stuff. Yeah, sorry. Don't worry about that. So I have the npm run build, just do cargo build. And also I have cargo.2ml, which is my cargo, my Rust package.json. That does not really nothing, there's no dependency, but I specify that my play type is not the classical Rust lib custom format types that Rust use for their dependency. It's a dynamic library and to produce different file depending on what OS you use. So that's basically all the code I have in my presentation. And I will back a bit to the theory before trying to make it work, just to explain the thing. This talk, I will talk a bit about memory. It's really simplified mental model of it to be able to talk about it. But I think it gives a good idea of what's happened, and I speak about the memory of a process. When I talk about process, it's exactly what you do when you open your task manager on Windows, Mac OS, or HTOP on Linux. You see a bunch of process, and we'll look at the memory of one process. If you launch Node JavaScript file, you have one process. That's part of the memory of the process, and you have an idea. What I represent here is not really obvious, is code in memory, because maybe you're aware of it. When you run a program, it's loaded into memory. So it takes a program from your disk and you load it into your RAM, and so your code is in the memory. And running a program means moving to a place to another in that memory that represents the code of your program. And so usually in C, when you want to specify where to start your program inside this big memory, where is your main function, you have a start symbol that you say, it's a label, start here. That's the address in the memory where the program starts. And after you move inside the memory, and so the program is running and everything. And here, in the same process, we will not have only the memory of the node code base, we will have a binary. We'll also have a dynamic library. So it's not snip, it's lib snip. There is prefix automatically added. And this is a Linux machine, but I make my slide on macOS, so it would be SO, but on macOS is dlib, like dynamic library. And I have 2 entry point, one add, and one concat, just for the sake of the example. What that would say is that rather than having a binary with a single entry point, which is a start, like what's the main entry point, we have really a binary that will be loaded into memory with several entry points. Like your memory, you can jump at one place, which will be the add function, at one other place, which will be the concat function. You can bring memory bring a binary from another language and just you will mix the two by moving inside the memory. That's the global idea. And I will just illustrate that by making my example work. No, that's that. So how to make that example work? I do npm run build. It will call cargo. It will build my library. So I have no tree. I have no target debug libsnip.so, which is here. Sorry. So Rust build that binary. I can just display what is it. I do target debug. So it's yeah, complex stuff. You say to me that basically it's a dynamic library. So I have my file. I have my file. I want to load into Node, so I will launch the Node RAPL. So now I'm inside Node, and I can do require some module within I'm inside. So I require my main.js. And will it work? It will not, because I don't do npm install. That's not part of the demo, but I will npm install. It's really fast. Yeah. I stress a bit my example. Okay, come on. Can do it npm. It will work. It will work. I'm confident with that. Sorry to not having done npm install before. It's just one module. I don't know what takes so long. Yeah.
What needs to be installed?
What is installed is okay. Don't care about that. What is installed is okay. Actually, I care about that. I changed as for example. I just remove that part. We don't care anymore. Oh, it's never existed. And install should say everything okay. Yeah, okay. Cool. The one thing we install is FFI dash any. Yeah, it's the what it's yeah, sorry. It's that thing. That thing where it's package from JSON and you need to install it. So back to my example, I launch Node.js process and inside another VPN. I try to require, and now I have an error that I expect. That told me that load the libsnip.so, but it can't find the symbol add. So it's like it load binary, but it can't find the add label. Symbol is really a label in your library. And to understand what's missing, I updated automatically my file. So I open it again. Sorry, I will rewrite it from scratch. Being src errors. I add one line, which is no longer. What is mangling? It's a compiler feature that actually your symbols, the label in your binary, are not the same that your function name. For several reasons. One is to make reverse engineering harder, and the other one is because if you have several add functions in your program, you will have several add symbols, and you can't do that. It will fail. So you have to say explicitly, I don't want the symbol to be randomized, to be changed to some complex string known only by the compiler. I want to first keep the add symbol. So now, if I do npm run again, yeah, launch Sraka build, and do Node again, and acquire. And I'm really happy because it works. So cool. I have my add function, but I want to test it to be sure it really works. Will it work? Suspense. Yeah, it worked. I don't know if it's maybe a bit small, but 2 plus 2 is indeed equal to 4. I do several tests to be sure it really works. It worked. I'm really happy. And so, since I'm really happy with that, I will update my example and I add another function, which is not concat. So concat is really like add, take one string, another string, return a string. And what it do is concatenate. It's 2 strings by putting them together. It's a string formatting. Pretty cool. So,
yeah, I have a question. What would have happened if instead of using I32, you would have used F32, and on the add provide 4 and 4 for the addition? Will, because in JavaScript there is no integer, will it kind of seamlessly work, or there is some kind of
and if you put null?
Sure. We can go to all corner case. I will just show my main.js. Actually here, you declare type. So I will replace int by float, and it will work. And here for the concat things, we say string. So we're really explicit about what we want. Obviously, this definition here should match this definition in Rust, but it sounds good, so I will test it. And then run it. Cool. Compile. Node. Cool. Can I record also my module? It works. It finds 2 symbols. Pretty cool. So concat snip dot concat. Yeah, I'm really a lot of imagination in my example. Yeah. And will it work? Suspense. It made Node.js crash. It's not like I had an error in my Node.js repair. It's like it made Node crash. It's really bad. My code was safe. Everything was really cool. I don't use any unwrap in Rust, but it crashed my Node process. So I'm really mad about this, and let's transition for an explanation. What happened? I have my little handwriting scheme of process, and this is memory used by code. It's code in memory. It's code I jump to different positions to read the instruction, but the process have more memory than that because it needs memory for variable, object, everything your living program uses. When you have a variable, you have to store them somewhere. It's memory, and basically the memory for almost all programming languages are split into 2. There is stack and heap. It's not really important, the difference between the 2 right now. For example, for the point of view of Rust, you put on the stack everything you know in advance at compile time, the size of the object. So if you already know the size of it, you put it on the stack. And if you don't know in advance the size of it, you put it on the heap. You don't really care about this detail right now, but we look at the stack. The stack has its name because it's really like a stack of a plate, and the plate are your function call. So for example, if I call the function A, it's put on the stack. If in the function A I have called to the function B, it's put on the stack. If the function B calls the function C, it's put on the stack. You get the idea. Go back to the function B, function A. If then I exit the function C, I go back to the function B. If I call now function D, and it's really like reminding what's the current function call you were in your program. You know here that you were in the function D, within the function B, within the function A. It's really cool because if you think about coding memory is really like the line of your program. I know I'm line 42 of my program. It's not the same to be line 42 because I was called by the function e, or because I was by e, by d, by t, by e. I mean, I have to remind how I get some. And that's what stack does. Continue again and again. And here I have different color. And what this color represents is our function in Rust. So it's not the same color because it's not the same kind of function actually. JavaScript function and Rust function does not lay out identically in memory. It's not the same thing. And also, when your program crash, you get a snapshot of your stack, and that's what we call a stack trace. So you were in F within E, within D, within B, within A, this kind of stuff. Anyway, so to make it work, we have to make an agreement. We have to make E and F be agreed on things like how do we represent argument, how do we represent return value, how do we organize that in memory, what convention do we follow to make two different functions of two different languages work together. And that kind of contract is called calling convention. It's a straightforward name, like we make agreement on how to call a function. And my example in my presentation is really cool, but there's something wrong about it, and maybe you spotted it if you were really, attentive. It worked with int. My first example worked. Why? It's weird, and actually it worked just by chance. I like to explain it like that. It's a hack. What does it mean it's a hack? It means that it could break in any minor release of the Rust language. It means there is no guarantee it will continue to work. If Rust decide to change how they represent or function layout, it will no longer work. And it works because it happens that integral are the same. E32 is what expect JavaScript was with an int, and the Rust calling convention is somehow retro-compatible with the C calling convention, the old language. But it's really a chance. We should not count on it, because if we build a word program on this hack, it could break at any moment. So I have a bit of writing explanation. FFin API expects C calling convention, Rust calling convention, that's what's used in listed, and Rust E32 happen to use the same memory layout than C int. It happened to be the same, it's really cool. But this cool truth does not hold for Rust strings that are really different than C char star. It's pointer of a char, it's an array of char. That's the way char is for character. We store C string as an array of character. And you remind us that. You know that. So, very cool. We have to change something into our programming. I will bring another example. Yeah. So I changed a lot my code actually. I open sleep. Yeah. No, I don't change a lot my code. One example. I add this thing, extern. Extern is not about how much public is your function. It's just about what is the calling convention you use. And this is a way to say, I will not use the convention of the C, the old programming language, which is the convention that expects JavaScript. So I say, my function in memory, the way it's layout, argument, return value, is the same as the C programming language. And this is like a contract that will not be break, because the C calling convention doesn't change in decade. It's not the case of Rust calling convention, which is unspecified, it's not a stable API, can change at any moment, this kind of stuff. Maybe you have aware of that. And now I have warning, and because I'm a really good programmer, I don't care about warning. It's, yeah, there's something that my computer tell me. But actually, I have to care about warning, because if I launch again my example, it will fail exactly the same way. But now I have warning, which is really cool, because before I had no warning at all. And it told me that string is not FFE safe. It means a Rust string could not be really represented as a C calling convention. I have to change it. I have to use something more like what I would write in C, which is a pointer of sharp. And there is type for that in Rust. There is compatibility type. So here my code changes a bit more. Here I import this stuff from stdffi, the C string, the C sharp, the CSTR. There's 3 ways of having string a bit more like the C language. And I change my concat function to now have 2 conversion functions, C sharp to string and a string to C sharp, to keep my computation rusty. I do the same line here, but I change the argument, I change the return value to have my function now take C sharp and return C sharp, which is what the C convention expecting. And to do that, I have borrowing conversion function. I will not explain because it's boring, and that could be code generated by GitHub Copilot or ChatGPT. Don't care. Yeah, not really interested. Those complex stuff of just changing the string. Really cool. So now, will it work? I will compile. Yeah, everything okay. No warning. Really happy. No warning. Okay. So I run Node. Does it load? Yeah. Found the symbol. Everything all right. And here, I do my concat stuff again. Okay, cool. And what's it? Whoa. I got a function that does not really do the concatenation of foo and bar, but it does not crash, it does not fail, no error. Really cool. And I have something really unexpected. I have no determinism. Like, sometimes the same thing, sometimes it change. Yeah, I have several times the same thing, but we should change, please. No, it changed, empty string. Yeah. Does anyone have an idea of what's happening right now? Yeah?
Is it just because in that function to convert string to a C post, the pointer, you moved the string because you passed the string by value, so it got reallocated after you call this function, and now it's going to be
yeah, so that's the right explanation. We are reading right now garbage memory because the string were free, were dropped by Rust. Rust released the memory where foobar was stored. So now there's no longer foobar in this basic memory, and we're just reading garbage, which have a name, actually, this kind of bug. It's called use after free. We freeze the variable, the memory, and we still use it after, which is a big security issue, by the way, but also right now a way to display random number on the screen. So it's really bad. We want to fix that. Yeah, so that's part of the demo. Sorry. How do we fix that? Yeah, I update my code. We had one line, which is this one, because yeah, we get the right inside. CSTR is dropped there. Meaning Rust have a mechanism to release the memory at the end of the scope. So it releases the memory, but we don't want Rust to release that memory because we want JavaScript to use it. So we have to tell Rust this std-mem, like memory management primitive, to forget it. This means don't care about this thing. Do not try to release the memory. It's not your problem. I want you to not release this memory. And with that little change, just one line I added. Oh, I did it again. Suspense. No, I should be able to make it forward. That's really cool because we manipulate strings. So if we manipulate string, we can do JSON serialization, deserialization. We can do everything. So cool. So we basically does all the complex stuff. We finish. Nothing safe. Nothing to add. One question that may arise right now is it it seems so complicated. Yeah, right. And why do you bother with Sraka? I mean, can we just do different process, like the REST process, which is a web server, and the JS, which is client, and they just discuss through HTTP REST API, and that's work well, and we do not have memory bugs, which are the one thing you want to avoid, especially with REST. And the answer is no. Why? Because we care about performance and we care about fast interoperability. And speaking about performance is always tricky because depending on measurement, what we care about. And I want to emphasize on the fact that we're not at all at the same scale of measurement because FFI just you move into your program memory. So your processor can do the work without hangout. It's just a continuous type of computation. If you use anything which is input-output, anything from your own operating system capabilities, like reading a file, calling a process, reading network, everything that OS gives you as a tool, it's like you're making your process in pause. And so if your process is in pause, the processor stop to make your process make job. And that is actually really bad because it's not like a small performance difference, it's a really big one. So actually we care about doing this, everything in the same process, in the same binary in the memory, without using any OS trick. Also, OS trick are OS specific, and the thing I show here is not OS specific. That's another reason. But just another question, we talk about fast, so we want, yeah, so no issue. We want to talk about safe interoperability, and FFI is not cool because we want something easy to use, that will not make my work program crash by mistake. It's kind of a normal expectation. And so the general idea is good FFI is a FFI you don't write. Meaning it's not the kind of code you will write by hand because it's so easy to make a mistake. Imagine I make a mistake in the prototype, the signature of my type function in main.js. I forget one argument, or I forget I may make the wrong type, or this kind of mistake you don't want to do. So actually you don't do it by hand. You have programs that generate that code for you. So that's kind of programs called binding, like binding code generation. And so, question, how do we implement REST code generation? Question. Do you have an idea? Yeah. Answer, macro. So answer is macro. It's the right way to do code generation. I have the last demo. Release, that's the last one. Maybe. Where's the I have another example, and my example is actually a demo with Neon. So Neon have different set of files, and I can look at it. I have, yeah, the Neon things. Yeah, 6 potential context, yes, result. It's more high level. And the question is, how does it work? And I can see how it works by using a tool called cargo expand that do the macro expansion. The macro in the code were here. That's the macro, Neon main. So actually, the code will be modified slightly. I can see that with cargo expand. Yeah, cargo expand. Yeah, I will open it in PI because it will be better. Expand it. Else. Yeah, and if I open expand.ers, yeah, we see that the real code after macro expansion is more complex. You don't have to understand it, but you have to spot that here we have unsafe external C, which is exactly the same thing that what it does, just Neon hide it and make it automatically. That's the idea. So I think that's the end of the talk. The code is in line, or maybe the repo is still private, but I will change it right away. It's a raw outside. And yeah, that's all. Do you have any questions? Yeah.
Presumably, like this Neon framework then takes care that the string does not just
Yeah.
Like in your example, you just forget about it, and it's if you do it 100,000 times, you forget about 100,000 strings.
Yeah. I mean, how does that technically work? Basically, I talk about ownership. The question was, does Neon take care of not leaking the memory? Like, STD may forget something, so it's now between the end of JavaScript. Will the memory be leaked? There is two approaches for that. The first one is to design custom handlers. Like you create a function to release the memory, and you want your user in JavaScript to call the function that releases the memory afterward. But actually, this is not really needed since it's. We'll speak a bit about ownership. It's not really ownership, but when a pointer became JavaScript object, it became within the scope of the JavaScript garbage collector. So actually, JavaScript will handle it with less control than what you will expect if you do it with primitives that you say, I want to free it right now, but it's not a buggy program. It's more like okay, it's now in part of the JavaScript world. And this can work because everything is the same process, everything is the same memory. It's not like different something. We are.
So it's actually already handled by the Node.js.
Yeah, by JavaScript. As I understand it, I never ran tested it. Maybe it's wrong what I just said, but I really believe it's works like that.
So in your example, the memory allocated for the concatenation, Kuba,
Yeah.
was then freed by Node.
No, it was free by Rust.
It was freed by Node.
Rust has a mechanism of every object.
After Node used it.
Yeah. The question was, no, before. Okay, the question was, if I have who frees the memory of my example where the memory were free before use. And that's Rust. And Rust has a mechanism, which is if the object is on the stack memory is free. It's a simple model, like you go out of the function, stack space is released. It's not really complex memory management for the stack. But what we care about is the object on heap, like string, where keep on its own memory space, and we have to take accounting of when we should release this. And Rust has a strategy for that, which is to work a bit like to work on the stack. When we go out of the scope, the lifetime of the value end, and that's normally the place where we call drop, which is destructor, which is mean freeze the value. So we go at the end of the scope of the function, and because the value was not returned, it just decided to drop it because we return not the value, but it reference to the value because it's as pointer or cannot really see it, or we go through the check of the memory model of Rust. So that's why we have to do a special handling in this case. I don't know if I my explanation is clear. If you have some question. There's a pizza here.
So when you want to test the right way, easy to test is a Rust and the integration between Node and Rust within Node. So this is the approach to test that it actually works.
I'm not sure the question.
So I want to test that the code actually works. So I can test the logic, which is like your concat function. I can test it in Rust, right? And
Yeah.
I want to check that the integration actually works because the delivery product must be at least, let's say, 10 times.
Okay, I get the question. The question was, if I do unit testing within Rust, I will not spot the bug. The question is how to spot the kind of bug we have. And that's the kind of bug we can spot with end-to-end testing. So you want to see what the workaround does to spot the mistake. But the general truth about it is really, you don't want to do that by hand, you already want to generate that, and you can trust binding generation. It generated code, the interface will match, and if it's generated code, you are really unlikely to make a mistake unless you have a bug in your engine, but it's kind of the same issue of having a bug in the compiler. You have sometimes tools that are broken, and you can do tests about that, and see them. So you see. Yeah, so I don't know if it's really answers the question, but
Yeah, partially, yeah.
yeah.
So the string type in Node, is that UTF-16 or?
It's a really good question. The question was string type in Node using UTF-16 rather than UTF-8. That's a different way to represent the Unicode writing. What's the chunk of bytes you plug into it? I believe Node use UTF-8. I think UTF-16 is no longer used in most places.
Right, so it's UTF-16. So I would have thought that Node, just guessing here, but I would have thought that Node is also UTF-16 to be compatible with the JavaScript engines in the browser.
Yeah,
I don't think so.
So, or ECMA, yeah. But then in those that yes. So then the C string FFI type, I guess that's ASCII or like it's not.
One more question. You told me sometimes Rust uses, some implementations abuse the macro system.
Yeah.
Do you think Neon abuses it, or what's your opinion on it? Is it an exotic use of it?
No, that's a good question. The question was, Rust tends to abuse the ergonomics of the microsystem, and is Neon abusing it, or will it be possible to do a Neon without macro? And I think macro is the right way to do it in this case. I mean, the wrong way to use macro is Rust is lacking of feature, or ergonomic feature, or syntax feature, and you want to put to test new compiler feature as macro. It's maybe what slow down compilation. But in this case, it's really cool to have a macro rather than, I don't know, an external tool. Because if you have an external tool, you can always forget to run the external tool. You can have the external tools that generate by engine, you forget to run it, and you code no longer match. So the cool thing about macro is part of the cargo build. If you change your code and you rebuild your project, it will change the binding because it integrates into the language. And for this specific use case, I think macro are really a good thing to do. Because in the code it will be
Otherwise, it doesn't work.
I know if there is any more question, but the piece down will be kind of code at some point. So
That was a good for
yeah,
one thing.
thank you.
Thank you. Fix the